first we have a 40-degree angle and a crate sitting on there. So FG for the crate is 588 newtons. And of course, get your components. So you got your Y component and your X component. So the Y component is 450. And the X component is 378. Okay, now what we have is a cord attached with a weight on the other end pulling it up. So the tension is what we want to know in order to give it a constant speed. If it's sliding up, that means that the kinetic friction is down, right? So the kinetic friction is going to be this way, since we want it to slide upward. So let's find the value of that friction, UKFN. So that's 0.500 times 450, which is 225 newtons. So your friction is 225. So now the sum of those two is what you need for tension to move up at a constant speed. So to get the tension, we'll add 378 and 225. You get 603 newtons. So that's the tension needed for part A to move up at a constant speed. Now for part B, we cut the rope that's attached, that's holding the weight up. When we cut the rope, we lose this tension force. And now the box begins to slide down. What else changes? How does it change? Right. The kinetic friction is going to reverse directions now because it's sliding down. So now that goes up 225. Stays the same because the normal force stays the same, right? The kinetic friction value is the same. So now you have an imbalance of forces, so do your Newton's second law for your two X forces. So negative 378 plus 225 equals 60A, and acceleration is negative 2.55 meters per second squared. So you got your acceleration. And now you want to know how far does it slide by the time its final velocity is 7.50. Now that's going to be a negative there because it's sliding to the left, so its velocity is going to be negative. So VI of 0, VF of negative 7, acceleration of negative 2.55. And now do your kinematics. Use the third equation and get delta D of 11 meters.